I'm really excited to announce that from January 2023, I'll be able to further support you with small group tutoring, intensive revision courses in the holidays, or online tutoring too. So if you find the way that I describe things useful and you'd like some extra help, then please get in touch via my website, www.cardiff-maths-tutor.co.uk. Also, if you could hit the subscribe button, that would really help me continue to make these free videos. Thank you. This is Mr. Ashton going through the Mathematics Numeracy Unit 1 Non-Calculator Intermediate Tier paper from November 2019. Okay then, so over the page you have the formula list, area of trapezium is blah blah blah, volume of prism is blah blah blah. We may use that, we may not. We'll see what comes up in the question, but don't forget that they are there if need to be. Okay then, over the page into question 1. We're told every year Abbey Young Farmers Club organises a sponsored walk. This year, the length of the walk is 20 miles. Calculate the length of the walk in kilometres. To do this, you need to know one of two formulae, or not two formulae, sorry, two sort of like facts that you need to be able to recall. Now, this is the one that I'm looking for to begin with. This is the one that I know off the top of my head. 5 miles is 8 kilometres. They're both integer numbers, i.e. they're whole numbers, so they're a little bit easier to remember, but you could use this instead if you wanted to. 1 mile is equal to 1.6 kilometre, which is exactly the same fact, but it's reduced that down to 1. If that's down to 1, you can then find anything you want, whereas if that's 5, you've got to look at multiples of 5, but that's exactly what we have. We have 20 miles. So what do I do to 5 miles to turn it into 20 miles? Times it by 4. Well, whatever I do to one side, do to the other side, so we find out the answer is 32 kilometres. I don't think this one is easier because in this case you have to times both sides by 20, which is not as straightforward as timesing 8 by 4. Part B. Last year the walk raised a total of £3,600. It cost £180 to organise the walk last year. Give the cost of organising the walk as a percentage of the total raised. Okay, they're looking for you to know the following formula, okay, which is basically what you got over the total, and then you times it by 100, and that'll equal your percentage. Now, you should know that from working out percentages in any test that you've done in any school tests up until, well, now. So I'm sure you've seen that before, and that's basically how you work out the percentage of anything. So it cost £180. The total that was raised was 3,600, and then we'd times that by 100. But here's the issue. We're in a non-calculator paper. So in that case, how are we going to work this out? Well, how we're going to work this out is by cancelling down the fraction, okay? And the first thing I can see is that there's a 0 on the top and bottom, i.e. I want to divide by 10 to the top and bottom, and that way then I've got 18 out of 360. 18 and 36 are both have 18 going to them. So now I'm going to divide the top by 18 and the bottom by 18 to get 1 out of 18 into 36 goes twice, and then there's still a 0 left there. So it's 1 out of 20 times by 100. Now, another way of doing this is basically saying, well, let's change 1 out of 20 into being something out of 100. What have I done to 20 to make it 100? Times by 5. Whatever you do to the bottom, do to the top. So it would be 5 out of 100. So my answer is 5%. Okay, so I might make sure that's really nice and obvious to look at. Part C. This year, walkers will be charged to take part. Abbey Young Farmers decide that charge in pence is equal to 3 times the height of the walker in centimetres. What is the height of the shortest walker who will need to pay a charge of more than £5? You must give your answer to the nearest centimetre. Well, probably the key thing to work out here, or to spot here, is they've given a charge in pence and they've told us that in pounds. So we need to change that £5 into pence, so 100 pence in a pound, so 500p. So I need that to be at least 500p is equal to 3 times by the height of the walker. Okay, or just height. Well, what I'm going to do to find out what that height is I'm going to divide both sides by 3. But I've got absolutely no idea how many 3's go into 500. So I'm going to do 3 and then 500. 3 goes into 5 once, remainder 2. 3 goes into 20 6 times, remainder 2. And then it's just going to be recurring with 2's, isn't it? Then 6, remainder 2. So I'm just going to carry on what comes there afterwards. So then remainder 2 again, so 6, and it's what we would call reoccurring. So my answer is that 166.6 recurring would be equal to the height. Now that would be the height in centimetres. So what is the height of the shortest walker? Well, the height of the shortest walker, if you were exactly 166.6 recurring, you pay exactly 500 pence, and it said we'll pay more than £5. So because that's more than £5, then it needs to be the next height up from that. If you were 166 exactly, you pay slightly less. If you were 166.6 recurring, you pay exactly 500 pence, £5. So the shortest height is 167 centimetres. Okay. Focus that. Okay then, over on to the next page. Sound 5 sells pairs of earphones and USB leads. The Venn diagrams show the number of customers who visited the shop last Friday and Saturday. No one visited the shop on both days. No customers bought more than one pair of earphones and one USB lead. We're then asked the following. Earphones sell for £15 and USB leads sell for £3. How much did Sound 5 customers spend on USB leads on Friday? So first of all, they put Friday in bold. That means we're working with this day and we're looking for USB leads. So the USB leads is everything in this circle. So that is 10 and 5, which makes a total of 15 purchases of USB leads. Don't we pay £3 for a USB lead? So we need to do 15 times by £3, and that would be £45. Next one says, over the 2 days, how many customers did not buy either earphones or USB leads? So if we're not buying either USB or earphones or USB leads, how many customers did not buy earphones or a USB lead? Well, I'm assuming it'll just be these guys on the outside there, okay? So the numbers on the outside would suggest they didn't buy anything at all. These numbers here, the 25 bought just earphones, these 5 just USB leads, these 10 bought both. Here the same is true here as well. So I'm looking for 27 and 45. So if I add those two numbers together, 12, 6 and a 1 is 72. So I'm hoping it's that answer there. Okay, over the page, and we are asked the following question. It says, what fraction of Friday's customers bought both earphones and a USB lead? So here we go. What fraction of Friday's customers, so I'm assuming the customers, it says earphones, the Venn diagram shows the number of customers who visited the shop. Okay, bought both earphone and a USB lead. Well, so we're back to Friday here. So I just realised you can't see the question. Friday's customers. Well, that's 10 that bought both things. So to buy both things, we know it's going to be 10. And it's going to be out of the total number of customers. So the total number of customers that came to the shop is everything in here, okay? That's one of the things I was checking back at. It says the Venn diagram show the number of customers who visited the shop last Friday. So that's 25 who bought this, 10 who bought both, 5 who bought just those, and then 27 who bought none. So they're still customers, okay, I believe. So we should get then 25 and 10, which is 35, and 5, which is 40, and then 27, which is 67. So I'm assuming it'll be that answer there. But what I think is a little bit misleading, I'm just going to go and double check, is that you could sort of misunderstand and say, well, 10 out of 35 from those 10 there and 5 there. So 10 out of 40, which is also 1 out of 4. So let me just double check the mark scheme on that before we go too much further. It is the 10 out of 67 that we said, so they are including people who didn't buy anything as customers, but that is a little bit sort of off-putting, I must say. D, how much money in total did Sound 5 customers spend on buying earphones, USB leads on both on Saturday? So that's 30 earphone buyers, so that's 30 earphones, plus 5 USB leads, and then 22 who bought both. So we need to do 30 times by the cost of the earphones, which is £15. We need to do 5 times by the cost of the USB leads, which is 3. And then 22 that paid for both, so that would be a total of 15 plus 3. So that would be times by 18. Okay, 15 times 30, there's lots of different ways of doing that. I'm going to do 3 times by 15 to get 45, and then add a 0 on the end, so £450. I'm then going to do 5 times by 3, which is £15. I'm going to just line everything up, so units, tens, hundreds, etc. And then 22 times by 18, I don't know, so I'm just going to go and split it into 20 and 2, and 10 and 8 there. 10 times 20 is 200. 10 times 2 is 20. 20 times 8. 2 times 8 is 16, add a 0. And then 8 times 2 is 16. So that gives me a total of 200 and 160 and 20 and 16. Adding those together gives me 6, 9, 3. So that gives me a total of 396. And then adding those together gives me 0 and 5 and 6 is 11. 10, 11 and 16, and then 8 there. So my answer is 861. Okay then, over the page, and what do we have this time? Question number 3. Let me just move the paper, sorry. Question number 3. And let's move that to there. The students in Mr. Griffin's mathematics class all recorded how long they spent doing their last piece of maths homework. None of the students spent less than 10 minutes on this homework. All of his students attempted the homework. Mr. Griffin has drawn the frequency diagram to display the times recorded by students. He used the group width within 10 minutes. So this is 10 to 20, 20 to 30, and so on. That less than or equal to there means that you can, if you were exactly spot on 10 minutes, you'd be included there. Whereas this less than 20 here means that I can't include 20. 20 would be included in that category because that's where it has less than or equal to. We're then asked, did any student get all their mathematics homework correct? Yes, no, can't tell. Well, the answer is I can't tell. The reason why is because that's not always measuring. It's not measuring the percentage of people who are correct. It's measuring the time, okay? This measures the time taken rather than the score achieved. Okay, part B says, how many students are there in Mr. Griffin's maths class? Well, we know that between 10 and 20 minutes took five students. That would then, let's go and check the scale on this. 5 to 0 in a jump of 10 little squares tells me that one little square is worth 0.5. So that's one little square. So be careful here on what this answer is. This is 10. 2 down from 10 would be 9. That's 1 up. So 2 little squares would be 1 up from 10. So that's 11. That's going to be 7. And then this one is going to be 1 down from 5. So that's going to be 4. So I need to do 5, add 9, add 11, add 7, add 4. Adding them together, you may spot certain ones fit together quite nicely. So 9, 11 obviously makes 20. 5 and 4 makes 9, so 29. Add the 7 there is 36. Okay, the next question, it says, consider the students who spent less than 40 minutes on their homework. What fraction of these students spent 30 minutes on their homework, or 30 minutes or more? So we're considering only students who spent less than 40 minutes. So we're considering 1, 2, 3. We're considering 5 and 9 and 11. So that's 25 students. So I'm just going to make a note of that. We're ignoring the others. So 25 students. What fraction of these spent 30 minutes or more? So 30 minutes or more would be 11 out of 25 there. Okay, over on to the next question. Let me just get the paper looking nice and neat. Emily has drawn a conversion graph as shown below. She used it to help her brother understand how to convert knots into miles per hour. Complete each of the following statements. Now, the very first time I saw a question like this, I thought, well, you can't do that. 23 miles per hour. Well, I can't do that. This 23 is not on the scale, but 2.30 is. If I go and work out what 2.30 is, so I'm just going to get my ruler, and I'm going to draw over there, and I can actually read it off. It's actually a value that's on the line there, and come down there. I find out that 2.30 miles per hour is 2 knots. Okay, so 2.3 miles per hour is equal to 2 knots. Well, I don't want to know what 2.3 is. I want to know what 23 miles per hour is. Okay, well, what do I do to get that to be 23? I times by 10, so times this by 10 to get 20. So the answer there is 20 knots. Now, we can do a very similar thing here where it says 5 knots is equal to miles per hour. Well, 5 isn't on there, so I can't do it. Well, there's actually a couple of ways I could do it. Option number 1, which I'm not a fan of, but I will show you, is going up from 2.5. If I go up from 2.5 and come and read this value off here, then that'll be half of it, so I just double it. But the problem is that's not a particularly nice number to go and work out, and this is why I said I'm not a fan of it. My jump there, just like I did on the other question, is a jump of 1.15 in 20 little squares. What's that? Well, I don't know, and I can't easily work it out. So I'm just going to leave that one. I'm going to show you a better way. A better way for me would be to come from 1 and then go up and work out that is 1.15. Okay, so I'm going to make the statement that 1 knot is equal to 1.15 mile per hour. Well, naturally you think, well, I'm going to times both sides by 5 now, but looking at 1.15 times 5, I'm not 100% sure I know that quickly off the top of my head, so I'm actually going to go to 10. If I know 10 knots, I've just times both sides by 10, so that would be 11.5 miles per hour, and then what I'm going to do is halve it to find out what 5 knots is. So half of 11.5, well, half of 10 would be 5, half of 1 would be 0.5, and then half of 0.5 be 0.25, so combine those together will give me 5.75 miles per hour. Okay, and that's what this would have been, half of that, and then I would have had to double it, so I prefer the method I've done there. Okay, over the page. Miss Logan is calculating her next water bill. She knows that her fresh water usage is 20 metres cubed. On the water company's website, she finds the following. The wastewater output is calculated as 80% of the freshwater usage. Freshwater usage costs £1 10 metres per metres cubed, so £1 10 pence per metres cubed. Wastewater costs £1.50 per metres cubed. Calculate her water bill. So her freshwater, we're told up in the question, is 20 metres cubed. Well, we know that 80% of the freshwater is what they're calling the wastewater. So I'm going to write down, I'll leave a line here, wastewater equals 80% of 20 metres cubed. Lots of different ways to go and work that out. For me, the best one is to say, well, 10% must be 2. So 80% times both sides by 8 would be 16 metres cubed. Okay, so we're then told that fresh water, so if I do the fresh water down here, it is £1 10 times by per metre cubed. So for 1 metre cubed, so for 20, I'd times that by 20. So what I'm going to do is actually do the £1 times by 20 to get £20. And then I'm going to do the 10p times by 20, which would be 200 pence, which would be £2. So that answer is £22. Next, I'm going to work out what the wastewater is. So the wastewater is charged slightly more, it's £1.50. There's slightly less waste. So there's slightly less wastewater. There's 16 metres cubed of the wastewater. Okay, so what I need to do is do 16 times by £1, £16, 16 times by the 50 pence, well, that's half of £1, so this would be £8, so that total would be £24. So what's the cost of the water bill? Well, it's going to be your fresh water and your wastewater added together. So 22 add 24 is a total of £46 in total. Okay. Okay then, over the page. So the first thing we're hit with here, it says, in this question you'll be assessed on the quality of your organisation, communication and accuracy. That's 2 of the 8 marks available here. 6 are still for the maths, so that's your important bit. Top tips, using units throughout, using pound signs throughout, using kilograms throughout. Those sorts of things are really important here. Also, if you're thinking it, just state what the calculation is and just show that you're doing it somewhere rather than having a number miraculously appear. We're told that Liam buys 3 kilograms of apples and 2.5 kilograms of pears. Pears cost £3.40 per kilogram. So 2.5 kilograms of pears at £3.40 per kilogram. Just highlighting those two because they're linked up already. Liam pays a total of £12.40 for apples and pears. Calculate the cost of 1 kilogram of apples. Okay, the first thing I'm going to do is work out how much he paid on pears. So 1 kilogram is equal to £3.40. That's that second bit of orange that I've highlighted. So this is of the pears. Again, if I'm being assessed on that, then let's make sure I'm nice and clear. The next thing I'm going to do is work out what 2 kilograms is. So 2 kilograms would be double. So that would be £6.80. Well, because it's 2.5 I want, the next thing I'm going to do is work out 0.5 kilograms. So 0.5 kilograms must be half of £3.40. So what I might do is go and split it into £3.40. That's £1.50. That's 20 pence. Combine those together, £1.70. £1.70 there. So 2.5 kilograms of pears is equal to £6.80, add £1.70, which is 0, 15, carry the 1, 7 and the 1 is 8. So £8.50. So I'm just going to put a line there and just explain what this is. I'll say cost of 2.5 kilograms of pears. Now the total cost is £12.40. So if we take off the cost of the pears, we'll know what Liam spent on apples. So we can then say £12.40, take away £8.50, nothing take away nothing, 4 take away 5 we can't do, so steal one from there, 14 take away 5 is 9, decimal points should all be lined up, 1 take away 8 we can't do, so 11 take away 8 is 3. So that is the cost of apples. Cost of 3 kilograms of apples. So I'm now going to go and put it into something similar as I did at the start. I'm going to say 3 kilograms is equal to £3.90. So if I want to work out what 1 kilogram is, then I would divide both sides by 3. £3 divided by 3 is £1. 90 pence divided by 3 is 30 pence. So 1 kilogram of apples is £1.30. So I'm now going to go and state this is the cost of 1 kilogram of apples there. Okay, as far as I'm concerned, that would achieve all the marks. Okay, I haven't just had numbers popping up, I'm showing them. I could, if I really wanted to, come and add in there times by 2, times by 2, and then from here divide by 2 and divide by 2. Here I could explain what I'm doing, so I could say halving £3.40, just to explain to someone who's looking at my work, okay? But it is relatively obvious what I'm doing because the way I've laid it out, okay? Question 7. Katrin considers data she will need to collect to find out if people are happy with their bank. Katrin includes the following questions in a questionnaire. Write down Question 7. Katrin considers the data she needs to collect to find out if people are happy with their bank. Katrin includes the following questions in a questionnaire. Write down one set of possible groups that could be used to answer options for each of these questions. Question number 1. How old are you? Well, in terms of that, the groups of questions that we could ask, we need to make sure that they do not overlap and there's no gaps, okay? So basically that no one is missed and that there's no overlaps between them, okay? So in terms of what we could ask for, well, who's likely to have a bank? Usually children don't have it, but they could be asked, okay? So we need to make sure that we have it. So one of the groups I'm going to ask for would be maybe something like under 18 years old. Under 18 years old. The next one I'm going to have is sort of young adults, okay? So I'm going to have something like 18 to 21. The next thing I would have is 22, so no overlap. So 18, under 18, if I'm under 18, 17 or under then that's the box I'd tick. This one here, 18 to 21. Then 22 to maybe something like 30. There'll be no need to have common groups going up here. It's sort of like generations that we're looking for here. Then maybe 31 to 50. And then finally 51 or over. Okay, so something that we're looking at for something like that, okay? Next question says, if you have a bank account, how happy are you with your bank? So we need to give down some different definitions here that people can tick. And you probably have seen these before, okay? So it would be something like 5 boxes where you would say extremely unhappy, unhappy, neither happy or unhappy, happy, and then the complete opposite of that one, so extremely. Apologies if I spelt the word extremely wrong. I am dyslexic, so now and again I get the spellings wrong. Sorry if I have. Okay? Or extremely happy. So those are the sort of things that we're looking for there, to give a certain number of different options. You can maybe get away with just the 3, but this way here you sort of got into like the sort of like the absolute maximum. People could be extremely unhappy, would be someone who's very annoyed with their bank. Okay, over the page, question 8. Shauned and Rodri are making a kite. The diagram of the kite they are making is shown below. AC and DB are the diagonals of the kite. Okay, I might go and write these on because usually they're put in for us, okay? So A to E, that length there is 22. E to C, this bit here then is 28. And then finally D to E is 20. Okay, so that's what they haven't put in. They just expect us to do that. Usually they do give you those bits of information. Rodri makes a statement about their kite being able to fly in strong wind. He says the length of the long diagonal, so the long diagonal is that length there, must be at least 120% of the short diagonal. So that's this one here, corner to corner. Okay, now I was about to say this before. Now this would actually be running through, this would be the midpoint here, definition of a kite, so that's also 20 centimetres. Okay, so I'm going to say long diagonal, it then says assuming Rodri is correct, should their kite be able to fly in strong wind? The long diagonal is equal to 22 centimetres add the 28, which is the 2 adds on to that 30, so then 50 centimetres. And then the short diagonal is going to be 20 times by 2, or 20 add 20, which is 40 centimetres, okay? Now, from here, I've got to show that it's 120% of the short one. Now, I know that the short diagonal is 100% would be 40. So to then go and find 120%, I'll go and work out what 20% is by dividing this by 5. And dividing that by 5, which gives me 8. And then if I add those two together, I get 120% is 48 centimetres. I should say centimetres. Well, we actually got 50. So yes, absolutely fine. So yes, should fly in strong wind. Okay, because of the fact that we got 50 and it says that it must be at least 120%. Well, if it needs to be at least 48 and we're 50, then yes, it's absolutely fine. Okay, over the page on part B, it says, I probably need this question still, so I'll leave that there, sorry. Shauned says the best length for the tail on the kite depends on the area of the kite. Shauned refers to a table below she has seen on the internet. So the area of the kite is less than 500 centimetres, you need a tail of 2 metres, and so on, okay? Between 500 and 900 is that, and so on. Work out the best length of the tail for Shauned's and Rodri's kite. Well, if you come back to your kite here, you've got a triangle here and a triangle here. Now, you know that's 40 both times, so 40, 40, and then the height is the bit that goes up through the middle, so here is 22, and then here is 28. So we just want to go and work out the area of the two triangles. So I'm going to just say top triangle is equal to base times height divided by 2, okay, or half base times height. So that is 40 times by 22 and then divided by 2. Okay, so what I tend to do is just go and work out the whole thing and then divide it by 2. So 40 times by 22, I'm just going to split the 22 up into 20 and 2, and then 40. 2 times 4 is 8, 0 and 0 is 2 zeros there, 40 times 2 is 80. So that answer is 880, and then I divide it by 2 to get 440 centimetres squared. Okay, I now need to know what the bottom triangle is. So again, it's base times height divided by 2, so that's going to be 40 again, times by a height, this time is of 28, and then I want to divide that by 2. Now, exactly the same, I don't know the answer to that, so 20 and 8 and 40, so I'm going to get 800 again, 8 times 4 is 32, add a 0, and then add those two things together is going to give me 1120 centimetres squared, but I need to divide that by 2. So then 1120, so I'm going to split that into 1,000, 100 and 20, and half each of those, we get 500, 50 and 10. Bring those together will give me 560. So it's 560 centimetres squared for the two different triangles, that one and that one. So what is my total area? Well, you add them together. Total area equals 560 add 440. If I add the 40 on, I get to 600, and then add the 400 onto that, I get 1,000 centimetres squared. So which one does that fit in? That fits in this category here between 900 and 1,200. So the tail equals 3.1 metres. Always make sure that you've actually answered the question that they've asked, which I have done there, okay? Okay then, over the page to number 14. It says Waldo doesn't mind which type of pasta he buys. In a supermarket, Waldo sees that there's 3 packets of pasta shown below. So we've got these 3 different types of pasta. It then says which pasta offers Waldo the best value for money. Now you will notice that these are all different measurements of pasta. So there are 2 ways to go here. We can either bring it all down to one measurement that's lower, that they all go into. So for instance, 500, 400, so we could go to 100, and then we could make that 100 quite easily. So we could do that way, or we could find a number that they all go into very nicely, and then just make them all a bit bigger. Then we just compare, once we have the same weight, we compare to see which one has the cheapest price, okay? So we could do the 100s, or we could go up to, now if we do 1,000, that goes into 1,000 quite nicely, that goes into 1,000 quite nicely. That one doesn't necessarily, but you can still force it to, okay? So I'm going to go with that option. The first one I'm going to do is 500 grams equals £1.25. So 1,000 grams, i.e. 1 kilogram, would be twice as much, would be £2.50. And that is this first one here, Strozza Peretti, which I've never heard of. So I know that. Now, fusilli, I do like a bit of fusilli. So I'm going to work that out now to be what its cost is in terms of 1,000. So the first thing I'm going to do is double it to be 800. So double of 96. So I've used this method a few times today. I'm going to split them, double them separately to get 192. So I'm going to change that to pounds now, £1.92. But I also need to then go and make that into 1,000. Now what I'm going to do is actually halve the 200 to get 48 pence, and then I'm going to add 48 pence onto that. So basically adding these two together means I have to add those two together. So I get 1,000 grams, and I will write down, add 48 there. 8 add 2 is 10. 10 and 4, 14, and then 2, £2.40. So my answer for this one is £2.40. So at the moment this is cheaper. And then finally, the rigatoni pasta. So rigatoni is going to be, So 250 grams is equal to 65 pence. Well, I'm actually going to double it twice rather than doing anything more than that. That gives me £1.30 to double it once. And then to double that again would give me the 1,000 grams, which would be £2.60. So the best value for money is the fusilli. And it's very nice pasta. Fusilli is the best value. And the reason why is because for the same amount of pasta, we're paying the cheapest amount. Okay? Okay then, over the page. It says, an old recipe is given below. Arrabbiati pasta sauce serves 4 people. 1 onion, 2 times 0.88 pound tins of tomatoes, and then 3 chilies. How many chilies would be needed to make the sauce for 48 people? We'll come here. We're given 4 people. We're looking for 48. What do you do to 4 to get to 48? You times that by 12. That means we need to times the number of chilies by 12. 3 times 12 is 36 chilies. Okay, so they've eased us into that one. That's quite a nice start. Next question. How many kilograms of tinned tomatoes are needed to make Arrabbiati pasta sauce to serve 20 people? Now, 2 things, maybe even 3 things. Kilograms, they've given us the answer in pounds. Also, we're given the recipe for 4 people. We now want it for 20 people. Recall. You need to know the following. 1 kilogram is equal to 2.2 lbs, pounds, okay? You need to know that fact. If you don't, you need to make sure that you know it, okay? You need to learn it now. So let me just make sure there's a reference there. You need to learn that fact. So 1 kilogram is equivalent to 2.2 pounds. Now, I know that we have 2 lots of 0.88, so I could work that out in a second, but I know it's not going to be 2.2 pounds, okay? It'd be 1.1 to make it that. I also know that I'm going to have to times this 4 by, I wish I'd gone underneath, by 5 to turn it into 20. So I need to do 2 times by 0.88, and then I need to actually times that by 5. Now, rather than struggling with this and saying, right, 2 times by 0.88, then times by 5, multiplying is commutative. That means I can do it in any order. And there's quite an advantage here of doing 2 times 5 first, which is 10, and then doing 10 times by 0.88, which would be 8.8, okay? So 8.8 pounds of tomatoes needed. Okay, well I know that 1 kilogram is equal to 2.2 pounds. Well, what do I do to 2.2 to make it 8.8? Hopefully you can see that it's times by 4. So whatever I do to one side, do to the other. So we'd have 4 kilograms. We need to get 4 kilograms of sauce needed. So I'd just say something like, therefore, 4 kilograms needed for 20 people. I should say 20. For 20 people. Okay? Part C. A pasta factory in Italy produces 5 kilometres of spaghetti per day. How many centimetres of spaghetti will this factory produce in 7 days? Give your answer in standard form. Oh, lovely question without a calculator there. 5 kilometres per day. Then they've asked for it to be in centimetres rather than kilometres. They're trying to sneak us there, and in 7 days. Number of different ways to do it. First thing I'm going to do is write out the fact that I'm told. 5 kilometres equals 1 day. Okay. Well, if I need to work out 7 days, then I just need to times that by 7 to begin with. So I'm going to times both sides by 7. So we're going to get 35 kilometres in 7 days. The next thing I'm going to do is change my kilometres into metres and then change that into centimetres. So there are 1,000 metres in a kilometre. That's what the K stands for. K stands for 1,000. So that's still in 7 days. And then there are 100 centimetres. So 1,000, then 2 zeros, centimetres in a metre. So I'm going to times initially, nothing by there, it's staying the same, but this is just changed by units. So times by 1,000, and then I've times by 100. That's how many centimetres there are. But then finally it says, give your answer in standard form. Well, to give it in standard form, I need to write it as a number between 1 and 10 times by 10 to a power, and that would be my answer then in 7 days. Now to do that, I need to get that number, that decimal would have to be between the 3 and the 5. So that would be 3.5. If I put it in front, it'd be 0.35. Well, it's got to be a number between 1 and 10. If I put it after, it'd be 35. So that's where it goes. Now, the number of numbers after that decimal point is 1, that 5 there, 2, 3, 4, 5, 6 zeros. So, sorry, 5 zeros. So that one number and the 5 zeros gives me a total of 6. So my answer is 3.5 times 10 to the power of 6. Okay, over the page here. Agatha is paid in pesos. The tax rates are as shown below. Banned personal allowance up to 200,000 pesos is 0%. Standard rate 200,000 to 500,000 is 10%, and further rate over 500,000 is 35%. Her total earnings before tax are 6,000 pesos, so she's going to be somewhere within here. Calculate how much she's going to pay. Now, the first thing I'm going to tell anyone to do a question like this is to draw a bar to try and help them work out the different combinations of taxes that we have to pay. Now, this bar is going to represent the 600,000 pesos that she gets paid. Okay? Up to 200,000, so about, well, not about, exactly 1/3 of it, that 200,000 is paid at 0% tax. Okay, so absolutely no tax to pay on this bit here. Between 200,000 and 500,000, so quite a big chunk of it now, so that would be 300,000 pesos then, is taxed at 20, no it's not, it's taxed at 10%. Then what is left? So 200,000 and 300,000 leaves me with 100,000 left, and that's taxed at 35%. Okay, so what I need to do is work out 10% of 300,000. That'll just be 30,000 then. And then 35% of 100,000. Now that's actually quite straightforward as well. So 10%, 35% of 100 would be 35. So 35% of 100,000 would be 35,000, but I will show you a better way. 10% would be equal to 10,000. 5% would be half of that, so 5,000. 20% would be double of that, so 20,000. And then add together is one way of showing it into the minutest detail, but you can just use logic on that. Is 35,000 pesos. So the total amount of tax paid is going to be those two added together, so 65,000 pesos. Okay, over the page, we must be getting near the end now. Let's just have a quick check. Okay, nearly at the end. Okay. Let's have a look at this question. It says, Gwilym is stacking 6 boxes in his garage. The height of the garage is 2.5 meters, correct to the nearest 10 centimeters. As soon as they tell you that bit, you should realise that this is going to be a question on upper and lower bounds, okay? Now, for good measure, sometimes they're not even giving me the same units, okay? So we've just got a few things to be watching out for here. Upper and lower bounds. And I'm seeing that as soon as I'm reading that to the nearest bit there. Upper and lower bounds. Okay. If you're not sure what those are, go and Google them and get your head around those now. The height of his garage is 2.5 metres, correct to the nearest 10 centimetres. 5 of Gwilym's boxes each have a height of 40 centimetres, correct to the nearest 10 centimetres. The other box has a height of 55 centimetres, correct to the nearest 5 centimetres. Calculate the maximum possible gap of the stack of the 6 boxes and his garage ceiling. Now this is what we're going to do to begin with. We're going to work out the upper and lower bounds of absolutely everything here and make sure it's in the same units. So 2.5 metres would be 250 centimetres. So that's the height of the garage to start off with. But it's not really the height of the garage because it needs to be either a lower height or an upper height. Now what we're going to do with each of those numbers is we're going to divide them by 2 to find out the upper bound and the lower bound. So again, divide by 2 here would be 5 centimetres. This one here we have to watch out for. That's 2.5 centimetres. So we're now going to do a table, okay? So we have got the garage, and we're going to have a lower bound and an upper bound. Okay, now the garage here, let me make sure that L is nice and obvious, it's an L, is 250 centimetres in height, but it could be, take 5 off that, it could be 245 centimetres, it could be as big as 255 centimetres, okay? Now realistically, we know it can't really be that, but we do put that as our answer, okay? So we have it where you always divide that by 2 and then take off to find the lower bound, add it on to find the upper bound, okay? We realise that you can physically be the lower bound, but you couldn't actually be the upper bound. It then says 5 of the boxes have a height of 40 to the nearest 10. And then, so I'm just going to say 40 centimetre box, and then the other one is 55 centimetre box, okay? So the lower bound of that is actually going to be 35 centimetres because they're measured correct to the nearest 10 centimetres, so take 5 off, add 5 on. And then we have got the 55 centimetre, but it's measured more accurately, it's correct to the nearest 5 centimetres. So we take off 2.5, so it would be 52.5 centimetres and 57.5 centimetres. Now, in the garage here, there's the garage. We've got the boxes stacked as follows, okay? So we have that height there of the boxes, and then we have this gap here. That's what they want me to find. Now, I'm asked to find the maximum possible gap of all 6 boxes. So I want that gap to be as big as possible. So for it to be as big as possible, I want this to be the max height of the garage. Max height of the garage. There, that's what I'm writing there, sorry. And then I want this to be as small as it could possibly be. So it needs to be 255 centimetres, and then take away, it's going to be 5 of those boxes at the absolute smallest, so 5 lots of 35, and is going to be the 52.5 box there as well. So this is quite an annoying question to do that a calculator. 5 times 35, well, if we do 10 times 35, we get 350, then half of 350 would be, I don't know how much easier that is as well, 350, half of that would be 150, and 25 would be 175. And then 175 add the 52.5 would give me 0.5, 7, 12, 2. So it's going to be 255 take away 227.5. So I'll just finish that off as a decimal there, 0.0. And then take one from here and there. 10 take away 5 is 5. 4 take away 7, can't do it. So it becomes 14 take away 7, which is 7. 4 take away 2, which is 2. And then 2 take away nothing is 0. So my answer is 27.5 centimetres. Okay, so I need to just make sure that's obvious. So biggest gap equals 27.5 centimetres there. Part B. Let's look at part B. Inside one of the boxes is an old clock. Gwilym takes the clock to be valued. It is valued at £56. The clock has decreased in value by 30% from last year. Calculate how much the clock was worth last year. Well, last year it had its original amount, which we treat as 100%. It is then decreased by 30% and is now worth £56. 100% take away 30 leaves me at 70%. 70% of its value from last year is now worth £56. What I'm going to do is change that 70 into 100, but I can only do that through multiplying and dividing. So what I'm going to do is divide it by 7 to get 10%. If I know 10%, I can then times that by 10 to find 100%. Whatever I do to one side, I need to do to the other. So I'll divide 56 by 7 and find out that's £8, and then I need to times that by 10 to find out that 100% of its value from a year ago was £80. So it was worth £80 the year before. Over the page. On the 1st of July every year, Trefor estate agents record the time from when a phone rings to when it's answered. The time taken to answer the phone is recorded in seconds. The data for their agents to see is shown below. There it is in July 2018 and then in 2019 underneath. we've got it in a different chart. It then says, use the diagrams on the previous page to answer the following questions. What is the range of times taken to answer the phone in July 2018? Well, make sure you look at the right graph. July 2018 is here. The range is the biggest number, so this number here between 100 and 120. So that is a gap of 20 with 10 little squares, so one little square is worth 2. So that's one little square. Sure, you can't see what I'm doing, sorry. One little square is worth 2. So that would be 110, so this would be 112 there. And then this would be 10, 1 square down is 8. So it would be 112, take away 8, which is 104, is it? Yes, 104 seconds. Okay. What is the maximum possible range of times taken to answer the phone on the 1st of July 2019? So we're looking at this one here. Now the maximum range of times would be this answer here. So again, we've got the same range going, sorry, same scale going here. So that is 3 little squares above 100, so that's 106 seconds. And then it started, it took at least 20, judged by this graph here. So 106 take away 20 would be, I'll make that 86, so hopefully that's one of my answers there, 86. Okay. Next question. It says, the manager of the estate agents claims that there has been an improvement in the median time. Answer, between 2018 and 2019. Is this true? The median is the middle line here. So here it was 78. Now to work out the median time here, I need to come across halfway from the total. So 80, half of that would be 40. And that will tell me what the median time is. So the median equals, but you need to come down and read off this value here. So that's 2 little squares down from 60. So that would be 58, 56. It's come down massively. It was 78, it's now 56. Is he right? Yes. Median in 2018 equals 78 seconds. Whereas in 2019, it equals 56 seconds. So yes, absolutely much quicker this time. On the 1st of July, 75% of the phone calls were answered within. And that's knowing your box plot here. This is your min, this is your max. This is your median, this is your lower quartile, this is your upper quartile. Now it says here, on the 1st of July, 75% of the calls were answered within. Well, the 75% is the upper quartile. This would be 25%. This would be between 25 and 50. So they're answered within 100 seconds. Okay, so quite an easy one to go and read off there. This one here, I need to go and work out what the upper quartile is. So the upper quartile would be 75% of 80. But an easier way to do it, if the median is 56, the lower quartile will be 20, the upper quartile will be those two numbers added together to come off and read off the value. So if I come off here at 60, which is 3/4, come down there. This is what we call the upper quartile, which would be 75%. Let's just check it's the same one. It is 75%. And then here, I can see that there's 1 over the middle, so that must be 72. So now it's answered within 72 seconds. Okay then, over the page. Mr. Aston, nearly a great name, lives at 137 Ford Uchel. He is ordering some new signs for his house and his gatepost from their website. We're told that all the signs on the website are mathematically similar. Okay, so a little thing just to be wary of here. Just know that there's going to be some sort of scale factor. He selects a rectangular sign on the front of his house. It has the length 42 and the height 24. The digits 1, 3 and 7 on the sign are all 18 centimetres high. The rectangular sign for Mr. Aston is considering for his gatepost is 20 centimetres. Calculate the height of the 1, 3, 7 on the sign that he is considering. Okay, so we know that the small one times by the scale factor will give us the big one. So he's looking at buying a sign that has a height of 20, whereas the height of the original one was 24. Bit of a mean one without a calculator, I must say. So we know that the small one, 20 times by the scale factor, will give us 24. Well, how do I work out what that is? We'll divide both sides by 20 to get 24 divided by 20. So the scale factor, 2.4 divided by 2. So the scale factor is 1.2. Okay. Now, the signs on this one here, these are the bigger ones. Because the height is getting smaller, then these answers here are the big ones. So I want to do exactly the same thing again. The small times by the scale factor times by 1.2 will give me the heights of the big ones, will give me the height of 18 centimetres. Well, I just need to do the same sort of idea again, which is to divide both sides by 1.2. Now, here's the issue. I've got absolutely no idea what 18 divided by 1.2 is. So I'll start trying to change it into numbers that make my life a bit easier. So I'm going to change it to 180 over 12. I'm then going to halve each to get 90 over 6. Halve each to get 45 over 3. And then 3 goes into 45 15 times, so 15 centimetres. Okay, so slightly smaller as they should have been because the height went from being 24 down to 20, so that 18 goes down to being 15. Mr. Aston's gate post is 30 centimetres wide. Will the sign he's considering fit his gate post? Well, we know on the initial one it is a height of 24 centimetres and a width of 42 centimetres. Sorry, 24 and 42. That's taken from there. Okay. Now, if I'm going to go to this one here to have 20, I know that I've times this by 1.2. Well, that means that to work this one out, I need to divide by 1.2. Okay. So I need to do 42 divided by 1.2. And again, I'm going to use the same trick. I'm going to times top and bottom by 10, which is 420 divided by 12, which would be 210 divided by 6, which would be 105 divided by 3, and then I'm going to do 3 into 105. 3 into 10 goes 3 times, 3 into 5 goes 5 times. It would be 35 centimetres wide. Well, no, because his gate post is 30, so no, 35 centimetres is needed. And that was the very last question. We're just told that was the end of the paper, so I hope that's been useful. Thank you very much for watching.